All right, geometry classes. This is Coach Merlot, Mr. Merlot, and just want to first off say I'm really proud of you guys for being on here, looking up these notes from your teachers, and taking the initiative to get some work in while we're in this unique time. We're going to get through it. If you ever need anything, just reach out to any one of your teachers, and we're always here for you. So let's get started on 7.2, use properties of parallelograms. Today's learning target will be, by the end of today's lesson, we'll be able to successfully find angle and side measures in parallelograms. So the very first thing we're going to take a look at is if a quadrilateral is a parallelogram, again, quadrilateral meaning have four sides, then its opposite sides are congruent. If quadrilateral PQRS is a parallelogram, then PQ is congruent to RS, and QR is congruent to SP. When we look at our picture over here, we see our markings signifying that the two opposite sides are congruent. Which leads us to our next portion of the lesson is angle measures. If a quadrilateral is a parallelogram, then its opposite angles are congruent. Really encourage you in both these to kind of make some sort of marking to remind yourself that those words especially are important. If PQRS is a parallelogram, then angle P will be congruent to angle R. And angle Q will be congruent to angle S. And again, over here we have our markings that signify those relationships. The very last thing we're going to learn is in quadrilateral, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Consecutive, adjacent, next to. Supplementary, the sum of both angles will add up to equal 180 degrees. Therefore, if PQRS is a parallelogram, then X plus Y will equal 180 degrees. So we take a look, these are consecutive here. These are going to add up to equal 180, as well as these will add up to equal 180, so on and so forth. So now we're going to some practice problems. Number 1A, in the directions it asks us to find the values of each variable. We'll start with X. These are side lengths, and we know that since they're a parallelogram, because of our two sets of parallel sides and it's a quadrilateral, then these two sides will be set equal to one another. X plus 6 is equal to 13. We're going to subtract 6 on both sides. Therefore, X equals 7. And then we look at Y, and we see that they're opposite angles, F and H. And from what we learned earlier, opposite angles are congruent. Therefore, this one's pretty simple. Y equals 68 degrees. Moving on to our second example. Again, we'll start with X. X is a side length. We know that the opposite sides in parallelograms are congruent. Therefore, we'll set them equal to each other. I know many of you that have me in class have heard me say that expression before. Set them equal to each other. We're going to add 3 to both sides. Now it becomes the algebra part. Divide by 2. X equals 20. Take a look at our Y's. Y is opposite 123. Therefore, Y will equal 123 degrees. They threw a new one in there for us to find Z. And Z is not opposite to 123 degrees. L and K, angles L and K are consecutive. Therefore, they're supplementary. They add up to equal 180 degrees. So we're going to add Z plus 123 degrees equals supplementary means 180. We subtract 123 on both sides, and Z will equal 57 degrees. Number 2. As shown, a gate contains several parallelograms. Its telling us in the reading that we have parallelograms. Therefore, all the rules we learned earlier, the 3 rules we learned earlier, will apply. Find the measure of angle ADC. So we take a look, ADC, this is what we want to find. We can put any variable there. I'm going to choose to use X. We are given DAB, and DAB equals 65 degrees, DAB. So the first thought that pops in my head is, what relationship do we have with angle A and angle D? Are they opposite or are they consecutive? And if we look, they're next to each other. We can see that they are consecutive. Therefore, they are going to be supplementary, which means we add them up and sum equal to 180. We subtract 65 from both sides, and X will equal 115 degrees, which means the measure of angle ADC is equal to 115 degrees. All right, the back of the notes here. We have one more rule, so this makes a total of 4 facts we have about parallelograms. If a quadrilateral is a parallelogram, then its diagonals bisect each other. You know, bisect means to cut exactly in half, 2 equal parts. The diagonals stretch from one vertex to the other, as we see in our picture. Therefore, since they bisect, segment QM will be congruent to segment SM. Segment PM will be congruent to segment RM. And again, we have the markings to prove that. That's a fact. If it's a parallelogram, then its diagonals do indeed bisect. Number 3, the diagonals of parallelogram VWXY intersect at point Z. Find the coordinates of Z. So this can be a challenging problem, but we have to go back to what we learned before. And if we really think deeply on what is Z, Z is a midpoint to WY and VX. So we just have to pick one set of diagonals, either WY or VX, to solve for this. I'm going to choose VX, and the reason I'm going to choose VX is because the coordinate of V is 0, 0. It's the origin. And X is going to be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So 7, 6. And since we know that earlier up here, where you can see my pen in the upper right hand corner, M is a midpoint of these bisectors, and that's what Z is. So we're going to use our midpoint formula. And if you remember what our midpoint formula is, we are going to add our X values of V and X. So sometimes it's written as X1 plus X2. It really doesn't matter. Divide by 2. And then the Y's as well. As long as we start with X1, we're going to start with X or Y1 over here as well. V's X is 0. X's X is 7. V's Y is 0. X's Y is 6. We can reduce these to the final answer of Z's coordinate being 3.5 and 3. If we look here, check our work, 1, 2, 3, there's 0.5 right there, and then 1, 2, 3. So that seems to be correct. Number 4, given that FGHJ is a parallelogram, find MH and FH. It's given that this quadrilateral FGHJ is a parallelogram. So one of the 4 rules is that its diagonals bisect. So we know that MF or FM is going to be congruent to HM. It's going to be 5. We also know that MJ and MG are also congruent. We don't know their values, so it's going to make those markings like that. So the question asks us to find MH. MH equals 5, and then it also asks us to find FH. So FH, we're going to add both those segments together to get us 10. That's what we have. At the very bottom of your notes, you have properties of the parallelogram. These are what we learned throughout the lesson today. And we're going to take those properties, we're going to take out our foldable here. And Miss Turbrek sent me. She did a great job of that. And we're just going to insert the properties at the bottom of the lesson onto this foldable. So if we look here, we have our 4 properties, 1, 2, 3, 4, 1, 2, 3, 4 in our foldable. And it's great to have the foldable because we have everything that we're going to learn throughout the whole chapter on one sheet of paper to really help us. Opposite sides are congruent. And I'm going to draw that. If you want to write the word congruent, be my guest. Opposite angles are congruent. Again, you want to write it out. We also have opposite sides are parallel. Something I didn't go over, but will be in your foldable. And consecutive interior angles are supplementary, which means they have to equal 180 degrees. And the one that we have at the bottom here is diagonals bisect each other. So I'm going to make a little bullet point there. This is the one that I assumed in the notes, but it's on our foldable and it's really important to make sure we have down. Well, thank you for your time. I hope everything's going well with all of you. Like I said earlier in the lesson, if you need anything, your teachers are here for you. Have a wonderful day.